Hello friends, from previous year class we have discussed about how to make strategy to clear kset and what are the important and most marks gaining topics. So if you don't watch that, if you not watch that video, please watch and come to this topic. Okay, today we will discuss about 2024 previous year questions. First question will be choose the correct statement with respect to Zn2 plus and Mg2 plus suppression. So here they are talking about Zn2 plus and Mg2 plus suppression method. So we are knowing that to separate the cations like 2 plus Mg 2 plus, like these cations, we will always use the opposite charged resins. Okay, let us discuss about what are the options they have given. Mixture of Zn2 plus and Mg2 plus are usually separated using anion exchanger rather than cation exchanger. Okay, what is anion exchanger? Anion exchanger is the resin. It contains a resin which is filled with the anions. Okay, it is a resin which is filled with the what? Anions. If it is filled with the anion, then when a positively charged ion is kept here, then there will be a attraction force with the resin, so that it is I think it is a correct statement. So here they are telling correct statement. Okay, this will be a correct statement. And next will be the Zn2 plus can be absorbed from hydrochloric acid solutions on ion exchanger resins due to the formation of negatively charged chloro complexes. Okay, here we can confirm the above statement that Zn2 plus can be absorbed from hydrochloric acid. Here they are telling that Zn2 plus can be absorbed by HCl, so that H will be the replaced by Zn. So Zn is replaced by H and ZnCl4 2 minus will be formed. And since it is a anionic exchanger, so here 2 plus Zn2 plus will be replaced and ZnCl4 complex will be formed. And next statement, Zn2 plus is eluted with dilute H2SO4. We know that here hydrogen is replaced by Zn, so here in H2SO4 also hydrogen is replaced by HZN, so that if we take a funnel and here Zn2 plus are there, if we put H2SO4 here, then there will be a transfer of this Zn to this beaker. Since H2SO4 is the acid, it can easily break the complexes of Zn and form into Zn2 plus, and here there will be a Zn2 plus which can be eluted. Like this, these three statements are perfectly correct, and these three statements are related one another. So there is a trick, that is, if you don't know the answer, then also you can able to assume that it will be the correct answer by seeing the options. So most options are related with one another. Okay, answer will be the 4, that is all three statements are correct. Only first is wrong, only 2 is wrong, only 1 and 2 is wrong, and the correct option is all three statements are correct. And this is the conclusion, that Zn2 plus in chloride solution forms anionic complex like ZnCl4 2 minus, which are retained on ion exchanger. Okay, this will be reason for these two options. Okay, then what will be next? Mg2 plus does not form such ionic complexes, so it passes through enabling suppression. So here they are talking about the Mg2 plus. Here there is only Zn2 plus is there, they are not talking about Mg2 plus, but this line is given because it can be asked in 2025 also. This year kset can be, this question is favorable because last year Zn2 plus is asked, this time they may ask Mg2 plus, and this is separated by enabling suppression. Okay, and to dilute Zn2 plus, dilute acid is used because breaking of the complex and release of Zn2 plus will be take place. So three statements are all are correct. Okay, One question: why Zn and Mg are used here? Means why they are forming a question? Because Zn and Mg both are water. They can extract from the water purification, and there are many and many of useful of Zn2 plus and Mg2 plus. So questions from these two metals are questions in future also. We can expect questions from these two metals. So please note this point and focus on Zn2 plus and Mg2 plus. Not only from the ion exchanger, this is the chromatographic technique part question, which will be ion exchanger chromatography. We can also expect these questions from the HPLC, GC, and also what will be the reverse phase of the HPLC, what will be the normal phase of HPLC, and what polar solvent. Like these questions also we can expect from future. Okay, so let us discuss about second question. What will be the second question? In a typical DTA curve, broad endotherms and sharp endothermic peaks respectively indicate. So what will be the broad endothermic and what will be the sharp endothermic peaks will indicate? They are telling that it will indicate dehydration reaction, or it will indicate crystallinity reaction. Means broad will indicate dehydration, or sharp will indicate what crystallinity changes, or they can telling that broad will indicate crystallinity or sharp will indicate dehydration. This is the both are the vice versa, and they are telling that broad will indicate melting, broad will indicate crystallization or sharp will indicate melting, or broad will indicate decomposition or sharp will indicate glaciation. So here in these two options there is no dehydration. Okay, but in these two reactions dehydration is there. So that first to know about the what is DTA, DSC and TGA. These three are instrumental methods. So these will arise in 4th sem. So if you are a juniors, means first sem, second sem, just approaching first attempt for kset, you can neglect these concepts, but you are interested, so you can analyze the instrumental method. Which is easy and most marks carrying concept. Here also you can expect the question. This year in 2024 DTA is asked, but in future also they can, in 2024 they can ask about the cathodic and anodic voltammetry. Yes, yes, and anodic voltammetry, cathodic voltammetry. Like these questions also, cathodic voltammetry and cathodic voltammetry, anodic voltammetry. Like this, these both are also most important questions. If we come to this question, in DTA curve, this type peaks will arise. This will be there is an endothermic peak and exothermic peak. So for this peak, they are telling that they arise like this term. For this curve, we can say that first dehydration will take place. First dehydration will occur because of the water removal, so that broad peak will be arising. Since a fast release of peak will take place, so there will be the broad peak. And next there will be a crystallinity, means for the recrystallization changes time will take place, hence there will be the sharp peak. Like this they will happens, so that for dehydration it will be the broad, and for crystallinity it will be the sharp. So that first will be the right answer. This is for broad endotherms usually indicates the loss of water, so dehydration, sharp peak for the sharp crystalline changes. You can also this is a hint you can take from this. In XRT also sharp peak indicate crystallinity, and this uh, broad peak will indicate about amorphous. This is extra knowledge. For extra knowledge, there is will be the sharp peak like this. This sharp peak will indicate the crystallinity in XRT also. So anywhere if they ask about the sharp peak, you have to mark about the crystallinity only. If there is a crystal form, there will be the sharp peak will be arising. Okay. For another point also, for glass transition you can ask not a peak like structure. You are not observe like this or like this, but there will be the stepwise changes in anywhere. If you look at the glass transition, then there will be the stepwise changes, not like a peak changes. With the third question, which will be the carboxypeptidase contents. Uh, what will be the carboxypeptidase content? So if we see the options, there will be the Zn2 plus and hydroxys of CO2 and Mg2 plus and hydrolysis of CO2. So only Zn and Mg only, these are the different, these two minerals are different. So that I already said that Zn and Mg both are most important metals, which can be asked more times, so that you can be ready with these two element questions. Okay. And Zn2 plus and hydrolysis of peptide bonds, and Mg2 plus and hydrolysis of peptide bond. So if you see the question here, carboxypeptidase, here they have mentioned that peptidase means there will be the peptidase will be forming, so that hydrolysis of peptidase, so breakage of peptide bond will be take place. So the main thing is we are using zinc or Mg. This is the main thing to differentiate. You have to exclude these two options here. Only by seeing the options you can exclude two options, so that only two options are there. From this you can choose one. So if we conclude the conclusion here, zinc metalloprotease is used to hydrolyze peptide bond at the end carbon end of the proteins, so that no CO2 hydrolysis will take place, and Mg will not involved in carboxypeptidase. So answer will be 2. And here we will see the, okay, now fourth question. If we move to the fourth question, which drug is not a metallo drug for cancer? uh, Here also you can see just only options, and you can predict the answer. You can see that carboplatin, doxorubicin, oxyplatin, cisplatin. You are looking that there is a platin like a voltage there, and here it is different, means doxorubicin. If you don't read this medicinal chemistry question, then also you can have to attempt. Means here platin means platinum metal is involved, so that here they are saying which is not, so that these three are anti-cancer drugs, but doxorubicin is the what? Doxorubicin is the antibiotic drug. So that if you don't know the answer, then also you can make correct tick. This is the specialty. So that there is no negative marking, so you can attempt these questions like these questions also. So read the options carefully. If you don't know the question, then also you have to you can correct the answers. See here, carboplatin, oxyplatin, cisplatin are the anti-cancer which contain platinum metal, but doxorubicin is the anthracinal and antibiotic, not metal drug. It does not contain any metal in this drug. So this will also helpful for your future. And from this also they can ask in carboplatin which metal is present, in oxyplatin or cisplatin which metal is present, or these drugs are which for which disease these drugs are work as the anti medicine. So these are the questions may expected for the future. Okay, so next question will be the CN stretching frequency of complexes vanadium hexacyanide 5 minus, vanadium hexacyanide 4 minus, and vanadium hexacyanide 3 minus. So here the oxidation number is changing, means 5 minus, 4 minus, and 3 minus. So that they are telling increasing order. Okay, means here there is a increasing order of the complexes. Here we have to look the concept that how oxidation state and frequency is related. Before that we have to see that oxidation number oxidation number means what? If there is a vanadium, if there is a just vanadium, its electron density is more, since more electron are there in vanadium. If we convert this vanadium to vanadium 2 plus, then this oxidation number is increased, but its electron density is decreased. Its oxidation number increased, but electron density decreased. So that if oxidation number increases, electron density decreases, then frequency will be increases. We have to keep this in the mind that if electron density decreases, frequency increases. If resonance increases, frequency will decreases, like this. So that here if oxidation number increases, frequency will also increases. So this type of the concept you have to know before the attempting the answers. Now we have to know that here, see here, higher oxidation number, less back bonding, hence higher frequency of cyanide. Okay, means here vanadium 2 plus for this, because since here 6 and for here 2 minus, so there will be the 2 vanadium 2 plus, vanadium 3 plus, and vanadium 4 plus. Hence there will be the vanadium hexacyanide 3 minus will be the more. Hence for more electron density, stronger will be the pi back bond, hence weaker will be the cyanide bond, hence lower new CN frequency. Okay, hence which will have the higher vanadium number will be the lower, hence there will be the mixed proportion here. So that number 2 will be the correct option for fifth question. Okay, next question will be the bromine NQR spectrum of K2 tellurium Br6 will show how much lengths. First we have to write correctly K2 Te Br6. For this we have to correct K2 plus Te Br6 2 minus. Whenever they have given this type of the molecule, we have to convert this into like this. So you can easily identify this is the octahedral shape. Correct? This is the octahedral shape, means 6 bromine atoms are connected. Te 1 2 3 4 5 6. Right? You can neglect this K2 and just concentrate on this molecule, so that here A A A A, these are one type of the atmosphere, and for this another type of the atmosphere, so that there will be the two environment are present, hence two lines are present. That's all. If they have to given any type of the molecule, you have to written like this, and you have to solve this, and you will get the answer. There will be the simple type of the answers. They will confuse you, so that answer will be the two lines. NQR spectra will arise in third sem in inorganic chemistry. So whos are studying in first sem and second sem, or just completed the first year, they may focus on NQR, or else you can do this spectroscopy only, because it is more time taking. If you have a time, if you have a completed the easiest and most marks gaining concepts I have discussed already, which are the easiest and marks gaining topics, then if you have completed those, then you can come to spectroscopy, or else just do this spectroscopy part. So question number 7, let us discuss about following compounds will show two signals in fluorine NMR spectra. So they are saying which the following compounds will show two signals in fluorine NMR. Okay, those options are 1 and 2, or 1 and 3, or 3 and 4, or 2 and 3, which will show two signals. We have to know the structure of this. First, SF6. This is if we know that there are 6 fluorine atoms. Yes, uh, groups are attached to sulfur, so that 6 means octahedral. Hence, yes, right. You can draw like this also, or like this also. Means F backside and front. Since the all fluorine are equivalent, since it will show only one line or one signal in fluorine NMR. Okay, next will be SF4. This SF4 structure will be little complicated. Like this will having the structure like this. These are the two fluorines, and then F, F, and here will be the lone pairs. This is the structure of SF4. Since there are two, there will be the two signals. One will be the for this, and another will be for this. A, A, B, B. Since this will be the like this. If this is like there on this front, and one there will be back like this. Since this fluorine and this fluorine will give one peak, and these two fluorine will give one peak, so two signals. Okay, and then next will be the ClF5. In ClF5 we will get chlorine, fluorine. Here 5 are there, hence it will be like not like this, but it will show Cl. 2 will be back, and 2 will be front, and 2 will be back, and 1 is on the plane like this. Because of like this, hence A, 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 and it will be B. This is like Cl, this is Cl, this is like this. These two are the back carbons, these two are the front carbons, and this is the upside carbon like this. These are the front carbons, and these are the back carbon, which are equivalent. These four are equivalent, and this is like this. Hence this is A, A, B. Hence this will show two signals. So if we go to the next, COF4 for this xenon, and F, 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 and like this. These are the front and these are the back, and there is the upside like this, like this. Hence they all show equivalent A, like this, equivalent carbons. Sorry, equivalent fluorines. Here also these are equivalent, like, and here also these are all equivalent. But here this is the structure. Since octahedral is the highly symmetrical moiety, if any octahedral they have given any octahedral shape or any octahedral molecule, you have to name it as only one signal, since it is high symmetrical moiety. It is having high symmetry, hence it will always give only one signal, and SF4 will give two signal, since one is front and one is back and one is on the plane. Hence these two will give one signal and these two will give one signal. Here also this 4 will give one signal and this on the plane will give one signal. Here also this 4 will give one signal, since they are asked for fluorine. This is also 1. So two signals are 2 and 3. So that answer will be 4, 2 and 3. Okay. Now go to next question. Here, geometric cross section in barren of a nucleus A is equal to 125 and R0 is equal to 1.4 into 10 raised to minus 15 meter approximately is. They are telling about cross section. Then if we goes on cross section, then we will know the formula that cross section formula pi r square. Always it is pi r square. But here we have to know they given about the, we know the value of pi, right? And they have given r0, not r. So that we have to find what will be the r. So to find r, we know the formula r is equal to r0 into a raised to 1 by 3. So we will put r is equal to r0 into a, that is a 1 by 3. We know the r. Now that r will be put up in this formula, pi into r square, we will get the answer easily. So this is not the complicated problem. This is very easy problem. You already know that pi r square is the cross section formula. They have given just r naught. This is the trick we have to apply here. They have given a and r naught. We have to use these two and we have to find the r here. So if we got this idea, then it will be very easy problem. If we know the r, then we have to put up this in here and we will get the answer. Okay, next will be isotopes contain same number of isotopes. Sorry, not isotopes, it will be isotones. Isotones contain same number of protons, electrons, neutrons or mesons. Meson is the smallest than electrons. This will be kept in mind. And here C, neutrons will be same number. Here there are I have to give some of the points. Okay. Here they ask about the isotones. If in future, if they ask about the there are many types, like isobars are there and isomers are there, and also isotopes are there, and also isotones, which are asked now. Okay, did you know what are these? Here isobars means having the same mass but differ in atomic number. If I given the example for this calcium 40 20. If argon, it will be 40, 18. Here mass number is same but vary in atomic number. This is example for this. And if we come to isomers, this is also called as a metastable. If we know the mass spectroscopy, we know the isomers Cl, bromine, there will be the isomers, metastable states are there. Okay, means these are the same Cl like this, but differ in the mass number. Here there will be the extra energy is there, extra energy for one isomer. There are two same element is called isomers, so extra energy will be there. Okay, what is isotopes then? Now only discussed that isotopes are same protons. These are having same protons. For example, okay, you know hydrogen, deuterium, like this. These are having the same number of protons but differ in the neutrons. Here isotones are having the same number of neutrons, means 7 and also 7, but here it will be 15, like this. Here if we minus, here proton plus neutron, this will be the electron, right? Okay, here if we minus this, then 14 minus 7, 15 minus 7, it will be 8. Five, 6, 7. Wait a second. Here it is not 7. It is 6. Right? Carbon atomic number 6. So 6. 6 minus 14. It will be 8. Right? 8. This is the neutrons. Like this. 14 minus 6, 15 minus 7, 8. These are the neutrons. No, these are the isotones which we have discussed now only. These are the isotones which will be the same number of neutrons. For 10th question, we have to identify the radioactive capture from the following nucleus. Okay, here what we have to know that what is radioactive capture. What is radioactive capture? In always radioactive capture means there will be the capture, means there will be the like this. You can see here, this is the gamma, means gamma is entering. Here gamma is entering and neutron is going as a emitting. Yes, gamma is and absorbing and neutron is emitting. Here neutron is emitting, neutron is absorbing and gamma is emitting, right? And here is proton. Always proton is entering and this moiety is emitting from the copper to sodium. So here there will be the no capture because there is this type of the moiety. To neutralize this, there will be this type of. Next there will be the silver. It is same, both are having same for silver, so there is no capture take place, hence this will be the not a option, hence this is also not, hence here there will be the neutron is going out, so there is no capture, hence the option will be the B, because here gamma is radiating. You know the gamma rays which will goes out, so neutron is capturing and gamma ray is goes out, so there is a capture of from sodium to sodium from 23 to 24. Here 9 to 8. So there will be the neutron is going out. So there is no capture take place. But here from 23 to 24, capture is occurring. Here will be the lot of difference. So no capture will take place. Neutron value is decreasing here. And there will be the same number of 107 and 107. So this will be the correct option. Okay. Discuss about 11th question. The correct statement about both average values of position and as well as momentum of the 1D harmonic oscillator wave function is. They are asking about the correct values of wave function of both position and momentum. So here the x is the position and p will be the momentum. If x is equal to 0, not equal to 0, then we can't if position will be not equal to 0, then we can't identify the it is not called as harmonic oscillator, since it will be the anharmonic, since position will be varying and also momentum will also varying, hence this is not wrong. If position is varying and momentum is not equal to 0, then it is also not harmonic, since harmonic means what, there will be the perfect motion, hence this is also wrong. And here these both are like a inverse of this, hence this is also wrong, means this is not a harmonic. This is, since it is a momentum is there, momentum is 0 but position will be there, hence this is also not. But here both momentum and position for one dimension, not a 2 dimension or 3 dimension, so there will be not the momentum, only for the one dimension they are asking. So that for one dimension this will be the correct, because for one dimension there is only one 1D, since if we like this, then there will be the 2 dimension 1 2, this will be the y, this will be the x. They are asking just a point here. What for one dimension, what will be the wave function, hence here there will be the no momentum and also there will be the 0 position, hence there will both are equal to 0, hence 3, since it is a symmetric, only a point, not like this also, this is for the 2 dimension. If we draw like this, then it will be the 3D, 3 dimension. They are asking for 1 dimension. Okay, next, like a stationary icon wave function which is real, hence if for 0, both are 0, then it is impossible for the stationary state, since it will be the in the motion, hence if both are 0, then it will be the not in rest, it will be in the motion, hence there will be both are will be in the 0 state. Okay, next one, for 12th question. The ionization energy of hydrogen atom in its ground state is approximately 13.6 electron volt. The potential energy of helium plus in its ground state is approximately, means here helium plus, they are asking about the helium plus, means here one electron is lost by helium, means hydrogen has 2 electrons in its state and by helium there will be it has lost 1 electron, hence there will be the 1 electron less, hence for hydrogen we have this formula, since it has given the 13.6 electron volt and 13 point electron volt divided by n square into z square, so that z will be the atomic number which will be the 2 and n will be the s means 1, so that z is equal to 2, n is equal to 1, z square divided by 1 square, hence it will be minus 108.8 electron volt. Fourth will be the correct answer. So these are the simple, means ionization energy. What is ionization energy? If you know this, then it is simple. Okay, Okay, for 13th question, which of the following statements on the ground state perturbation theory involving zeroth order of energy E naught raised to 0, and for first order energy correction term E naught is equal to 1, and for second order E naught is equal to 0, which is false? For simplified, I am explaining this question that for the ground state, consider ground state as what? E naught is equal to 0, energy will be 0, and for the first order there will be the correction term, that is E naught is equal to 1, and for second order E naught is equal to 2. Hence the options are E naught 1 is average value of perturbation operator with respect to ground state of the zeroth order Hamiltonian. Means they are telling average value, E naught is average value of the perturbation operator. Okay, this will be the correct, because it is a average value, means it is giving the average value. Hence E naught is equal to 1 is necessarily negative. They are telling E naught is equal to 1 will be necessarily negative only. They are telling it has to be negative, it will not positive. And for the E naught is equal to 2 is necessarily negative. In the second statement they are telling that E naught is to 2 is necessarily negative, it has to be negative. And for the fourth statement they are saying that E naught 2 and E naught 1 is then upper bounded to the extent of the ground state, so that it is upper bounding. This is also correct. Okay, but and this is also correct. Okay, now there will be the conflict between these two statements. Okay, if you know the perturbation correction term for the second order, there is a formula, you know, that formula will be, wait, E naught raised to 2, that is equal to summation of n is not equal to 0, it will be n h raised to 2 whole square divided by E naught by E naught minus En by naught, like this only. E naught equal to 0. This check once check this formula. I am not sure about this, but like this only, that is like this only. And here the denominator is will be negative, since here n 0 is minus of n, then it will be the denominator will be negative. If denominator will be negative, then whole compound will be negative, so that if denominator will be negative, whole will be negative. Hence this is also correct. Why this is only not only negative? Because it is first order is always depend on h, always depend on Hamiltonian. If like this 0 h bar and 0 always depend on h, hence it may be positive or negative. Please note this question, this is very much important question, and here you can clear the three concepts, you can clear three concepts. Answer B is correct, since this is important formula. This is for the correction term, this is for second order energy correction term, this is second order energy correction term formula, and here denominator will be always negative, hence whole function will be negative. Please remember this. And here h on depending on h, it may be positive or negative, so this is the wrong. Okay, next question. Here they are asking for some one electron system. Okay, here they are giving one electron system, L is equal to 0 and M is equal to 0, correct. And n naught of e raised to minus alpha and n into 1 of 2 into 2 minus alpha e raised to minus alpha by 2. So this is for 2 for secondary, this is for ground state, and this is for excited state, refers to respectively, and E naught for ground state, and this is for excited state, and this is E naught is equal to E1 is equal to. This is the question, this is the given, and they are asking for the yields. If the variation wave function n2 minus, means they are asking about n2 means E dash. They are asking about the E dash or E bar N2 of 3 minus sigma e raised to sigma yields. They are asking about the average energy, that is E bar, which satisfy the following functions. This is the given, and they are asking about this for one electron system. Only for the one electron system, L is equal to 0 and M is equal to 0. The functions N naught e raised to minus alpha minus sigma, this is for E naught, and this is for ground state, and this is for excited state, and between these two, this is there, this energy is there, means this is excited state, this is ground state. Between this E naught is there. For simplified method, I brought this. Okay, now the options are E naught is greater than 0, greater than or equal to 0. This is 0, right? They are telling about the equal, and this is also wrong. Okay, which will satisfy. Here 0 is smaller, means here also they are telling that E naught is means E bar is greater than or equal to E naught. Okay, where will be the E naught? Here E naught. They are telling E dash will be the, or E bar will be the smaller than E naught. E bar will be the smaller than E naught. No, E naught is smaller than E bar. This is also not. Hence here E bar is greater than E1. This is E1. No, E1 is greater than E naught. I will write here E1 is greater than E bar and E bar is greater than E naught. This is the correct order, right? This is the correct order. Hence here E naught is less than E bar and E bar is less than or equal to E1. Correct? This will be the correct answer. So for this question, this is the correct answer, and this is the explanation. Like if you understand the question correctly, then it is easier. You always you have to read and you have to work out, not necessary. If you read the question properly, half of the concept is clear, and you have to apply this question with the respect to options. Then easily you can know, you can guess also which will be the correct option.